All right, guys, let's get started with math for week 2 of quadratics. So last week we learned about expanding and factoring quadratics when you had a monomial times a binomial. And then we briefly learned how to expand quadratics when you have a binomial times a binomial. So you could use an area model, you could use FOIL, or you could use a double distribution technique. So today we're going to learn to go backwards, how to start from the expanded form and take it back to the factored form. There is no common factor with all the terms in the trinomial, so you have to expand it back into two binomials. So first things first, I have a pro tip for you. So for this part of algebra and for a ton of advanced algebra and algebra 2, it sounds really basic, but just knowing your multiplication facts is so important to being able to do this well. So I strongly recommend you brush up on your math facts and consider that part of your homework for this week. So I want you to either print or make some flashcards. If you just know the facts up to tens, so from 0 times 0 all the way up to 10 times 10, you'll be in pretty good shape. To be in even better shape, go all the way up to 12 or even 15. And knowing all of those multiplication facts will really make you a lot stronger at expanding and factoring and just dealing with algebra in general. The way you should use your flashcards is you have just make them by hand just to practice your facts. So get out a whole stack of index cards, and on one side you put the math fact, and on the other side you put the answer, right? And then go through each one, hold up the fact to yourself, say what the answer is, and then turn it over and see if you got it right or wrong. If you got it right, then you put the card in the right pile. If you got it wrong, put the card in the wrong pile. And after you go through the whole stack, pick up the wrong pile and go through them again. Do that once a day for the next week, and you'll find yourself in a lot better shape and a lot stronger with it after just a little time. So, on to the lesson. A couple of quick reminders about expanding. So I'm going to get my whiteboard tools out to do this part. So when we expand, the technique I like to use most is FOIL. So you do the first terms, in this case it would be x squared, and then you do the outside terms, so x times 7. And then you do, my handwriting's terrible here, you do the inside terms, FOIL, inside terms, so that's those terms right there. And then you do the last terms, so 4 times 7. And then you have to simplify, so we've got to add together these terms in the middle. So x squared plus 11x plus 28. So notice when we turn it into its final expanded form, we have some interesting patterns with these that you might have noticed as you were doing your expanding activities. This term right here, 11, is what you get when you add 7 plus 4. And then this term here, the 28, is what you get when you multiply 7 times 4. So you can always pick out the numbers 7 and 4 out of those terms. 7 plus 4, 7 times 4. Let's see if that holds true with this next expression. X times x is x squared. Outside terms, x times 3 is 3x. Inside terms, 9 times x is 9x. And then last terms, last terms, 9 times 3 is 27. There we go. Got it. And then we simplify the whole thing. Sorry, I erased the whole thing. X squared plus 3x, I'm sorry, plus 9x plus 27. All right, simplify that whole thing. X squared plus 12x plus 27. Again, a really similar pattern. This number here, that's 9 times 3. And then this term here, that's 9 plus 3. So there definitely is a pattern that we can use to refactor if we just recognize this pattern between the middle term and the last term. So when you expand, you get expanded, or sometimes called standard form. which looks like this. Ax squared, the a in this case is 1, plus bx plus c. And when it factors out, b is d plus e, and c is d times e. So you can use that knowledge to refactor an expanded expression back into its factored form. So let me go ahead and get rid of the whiteboard tools now. And working backwards. So let's say we want to factor this expression, x squared plus 4x plus 3. So there's no common factor. None of these terms have nothing in common between all of them. X is in these two terms, but not in that term. 3 is only a factor of this term. 2 and 4 are only factors of this term, so nothing common. But we do see that pattern where this middle term, could be the sum of two numbers, and this one could be the product of two numbers. So you ask yourself, are there two numbers such that when I multiply them, I get 3, and when I add them, I get 4? And when I really think about it, 3 and 1 would do the trick, because 3 times 1 is 3, and 3 plus 1 is 4. So therein lies the clue. You do x plus 3, and then x plus 1. And I can't write with these whiteboard tools. I'm doing my best, everybody. X plus 3, x plus 1. To check your work, re-expand using FOIL and just check and make sure you're right. X times x is x squared. 1 times x is just x. 3 times x is 3x. And then 3 times 1 is 3. Combine your like terms and you get x squared plus 4x plus 3. So you can see that this factoring was correct, and I double checked it by using the FOIL method to make sure. So that is what we'll be doing in our next set of activities. At this point, open the Google Doc that came with this activity. I'm going to go ahead and close the pen here. This Google Doc is in two parts, so I'm going to post two videos to go with this. This video covers the first part, and then the second video will cover the special cases at the end of the document. So to practice with this idea of factoring and expanding, you can start with an area model, and you're welcome to use the area model for the rest of the problems if that helps you. Some people like them so much that they keep using them. So for this problem, x squared plus 15x plus 56, we know we've got two binomial terms, x plus something, and then x plus something else, right? And then when I multiply these two numbers, I get the 56. And then when I take those two terms and I add what's in these boxes, I'll get 15x. So this one here, x times x is x squared. And then we don't know what this is. We'll call this like question mark, and we'll call this one star. But if I add question mark and star, I get 15. And if I multiply question mark and star, I get 56. So you start listing out your factor pairs of 56. 56 could be 2 times 28, but 2 plus 28 is not 15, so that wouldn't work. It could be 4 times 14, but 4 plus 14 is not 15, so that doesn't work. It could be 8 times 7, and that one maybe we're on to something, because 7 plus 8 is indeed 15. So let's just get rid of the, how do I erase only using an eraser and not getting rid of everything? I don't know how. I'm just going to scribble. So let's say this is 7 and this is 8. This would make this 8x, and this would be 7x. And 8x plus 7x is indeed 15x. So those two binomials work. This one factors out to x plus 7. It's a little bit of lag here. X plus 7, there we go, and parentheses, and then x plus 8. All right, sorry about the bad handwriting, but there you go. That's what that factors out to. I'm going to go on to the next problem. So let's erase what we have here, and then scroll down. X squared plus 13x plus 30. Again, we will factor this using an area model. So we have x plus something, and then x plus something else. So interestingly with this one, these two numbers, when I multiply them, I get negative 30. So I'm trying to think of two numbers that when I multiply them, I get negative 30, but when I add them, I get positive 13. So let's start listing factors of negative 30. Negative 30 could be negative 1 and 30. It could also be 30 and negative 1. Or sorry, negative 30 and positive 1. There you go. But if you add those up, you don't get positive 13. So we'll go on to the next pair. It could be 2 and 15, but one of them would have to be negative. So let's say that one's negative. Negative 15 plus 2 would be negative 13, not positive 13, but I feel like we're close. What if we swap them? Negative 2 and positive 15. And that one looks like that might do the trick, because positive 15 and negative 2 is equal to positive 13. So one factor is x plus 15, and then one factor is x plus negative 2. And then that would be negative 2x, and this would be 15x. And if I add together 15x plus negative 2x, I do indeed get 13x. So that's the final factored form of this expression. It would be x minus 2. My 2's are not coming out very good. I'm sorry, guys. I'm trying my best here. X minus 2 times x plus, oh dear heavens, 15. Okay, a little lag. I don't know if you can see that okay. I'm going to scroll down here. So there's tons more problems for you to work on factoring. Again, it really helps to know your multiplication tables. Practice with these. The answers are in the next document, and the next video will cover special cases. Okay, I'll see you then.